It's 2020, and there has been a coronavirus outbreak that has persisted for months now, resulting in worldwide quarantine. Scientists need to work quickly to develop a vaccine the world so desperately needs. Let's say a certain scientist experiments by recruiting one person sick with the coronavirus. The scientist gives the sick person a drug. After a period of time, the person got better. Did the drug work? No. We can't say for sure because sometimes people just get well on their own. The scientist tries the experiment again, with two people sick with the coronavirus this time. One person is given a drug, and the other was just observed as is. At the end of the experiment, the person who was given the drug got well, while the person who was not given the drug stayed sick. Did the drug work? No, we can't say for sure because these are two very different people with different bodies and immune systems. The person who was given the drug could have been a low risk patient and therefore was going to get better eventually. We'll never know. Okay, let's try this again. The scientist recruits two groups of 10 people sick with the coronavirus this time. One group is given the drug, while the other group was observed as is. At the end of the experiment, the group who was given the drug was observed to have less casualties than the group who was not given the drug and was observed as is. Did the drug work? Again, we can't say for sure because, like the second scenario, the groups are still made up of different people, all with different bodies and immune systems, low risk and high risk. The people recruited for the group who were given the drug may have been healthier and more low risk as compared to those in the group who did not receive the drug. In this scenario, the groupings could have looked like this, where there were more low risk people in the group who were given the drug, or this, where there were more high risk, on the verge of being a casualty people in the group who were not given a drug. There are so many possibilities that we cannot say definitively that it was the drug that helped these people get better. Okay, we better hurry up. The world is getting worse and worse by the second. If having two groups with 10 people isn't the solution to minimizing the effects of the extraneous variables, what is the solution? Hmm. Well, what if, instead of groups of 10, the scientist recruits 100 people sick with the coronavirus to partake in the study? The scientist flips a coin to determine and segregate the groups of 100 to two groups with 50 people each. One group will be given the drug, while the other will be observed as is. At the end of the experiment, it was observed that the group who was given the drug experienced less casualties than the group that was observed as is. Can we now say that the drug worked? Yes. There were 50 sick people in each group, and these sick people were placed in each group via the flip of a coin. In this scenario, the biases of the researchers were removed through the randomization of treatments given to the participants. Doing so will equally distribute the high risk and low risk people to both groups. What can we conclude from these scenarios? We randomize treatments in order to make our studies more generalizable. A goal in psychology is to be able to predict behavior, and this is why generalization is important. Otherwise, what is the whole point of doing all these experiments? In the general population, there are all kinds of people, and all these people are different. Randomizing the assignment and or order of assignments to participants will distribute prognostic factors, both known and unknown, between control and experimental groups. And this setup will be best to help us, researchers, generalize our studies and predict behavior. A bigger sample size will also increase representativeness of the general population, as the general population is big. Now that we know that the drug works, we can now mass produce and distribute the drug to all parts of the world. Look, the worldwide infected rates and death rates are already falling. Thank you for helping a certain scientist test their drug. You helped save the world.